Hello, everyone. You are welcome to today's lesson. And today's lesson, as you can see on your screen, we are going to look at correlation and regression. Okay, but we won't look at it in entirety. We'll be looking at one aspect of what correlation and regression, which will be you finding the correlation coefficient and rank correlation coefficient to be specific and use that to interpret your result. The first aspect, which will be the graph, where you'll be asked to draw your line of best fit and use it to, okay, what do you call it? Your line of best fit will be the same as your regression line and use it to predict or find the equation of this regression line and use it to predict any given value. Whether X, you use it to predict Y, or Y, you use it to predict what? Your X. Okay, we are not going to look at that. We are going to look at, okay, just as I said, the Spearman's rank correlation coefficients. Even in the rank correlation coefficient, we will do, or we'll zoom in, okay, on one, which is the Spearman's rank correlation coefficient. So without much ado, okay, let's look at the main objective for today's meeting. So by the end of this lesson, okay, you should know how to find the rank correlation coefficient and Spearman's rank correlation coefficient, okay, to be specific, and how to interpret what your results. So basically, this will be the main objectives for, okay, this morning's what meeting. So quickly, let's go and look at what we have there. So I will draw your attention to all the critical steps that you need to know as usual. Okay, so we are looking at rank correlation, but specifically Spearman's rank, okay, correlation coefficient. Okay, so usually it's denoted by, all the rank correlation usually denoted by R. The sub here, okay, is for the name. So Spearman's, R for Spearman's. And that will be equal to, it's a formula where you need to know this. And this formula, again, you are lucky in case you forget. And I pray you don't forget. You have it in the statistical book or the formula book, what we call the four-figure table. But in actual fact, it's not the four-figure table. Four-figure table is one aspect is contained in that, okay, formula book. Okay, so take note. So in case you forget, you have it there. You shouldn't get it wrong. And here, we are saying that your Spearman rank correlation coefficient will be equal to 1 minus 6 sigma d squared over, okay, it's not all over. It is only your 6 sigma d squared, that is over n into n squared minus 1. Okay, so n squared minus 1 in brackets. So you have parameters. You have d and you have what? N. So here your D will be the difference in rank. Okay, so usually you'll be dealing with what? Paired observation. You can see that in statistics, okay, what we've done so far, usually we dealt with only one variable. Okay, so that was a univariate, okay, data, one variable. That's why you have X, okay, class midpoint X. Or when you are given the table and it's on group frequency, your categories will be regarded as X. If it is raw, you still get X, only one variable. Okay, however, with this one, we'll be dealing with what? A bivariate what? Situation, meaning we'll be dealing with what? Two variables. Okay, so your variable X and your variable Y. Okay, you rank them. So in this case, we are saying that your D, this is how you get your D. Your D will always be equal to, okay, your rank of X, okay, minus the rank of Y. Okay, so rank of all your X values, okay, minus the rank of all your Y values. Okay, and it's not always that, okay, it will be in X and Y. Okay, so take note. It just your rank of your first category, okay, minus the rank of your second category. That's all. Okay, only that usually represent the first category by X and the second category by Y. But you can even use R sub 1, R sub 2, where R sub 1 would be, okay, the rank of the first category values, and rank sub 2 will be the rank of what your second, what do you call it, category ranks. And you have what? N. N will be the number of paired observations. So you can see that I said you'll be dealing with bivariate. So each X will have its corresponding Y. take note. So it will always come, okay, in terms of pairs, X and the corresponding Y. However, you should know that your R sub X, okay, must always be between two values, which is -1 and +1. Okay, if for the special situations, if you have your R to be equal to +1, the interpretation is that, okay, whenever you are looking at correlation, you can see that we are looking at how, okay, two or more variables are related, but here we are restricting ourselves to two. So when your R or R sub X is equal to 1, okay, we will say that there exists a perfect positive relation between your, what do you call it, your variables. So meaning if one increases, okay, the other automatically must increase. That's a positive relation. We can have another extreme, the other extreme. Your R sub X can be equal to -1. Okay, so I'm giving you, okay, the extreme interpretations, extreme values, okay, interpretation. So if your R sub 1, okay, R sub X, I should say, is equal to -1. Again, there is a perfect, okay, relationship. Only that this time around, the relationship is negative. So inverse, negative. So meaning an increase in one will bring about, okay, a decrease in the other automatically. Is my point well made? Okay, so +1, okay, you know, it's positive. All the positive relation will tell you that an increase in one will bring about, okay, an increase in the other. Only that when we say it is perfect, then it means we are going to, okay, have a bigger value, okay, in terms of the positive. One changes positively, the other will change positively. Okay, so the other will be what? Will be positive. But it is the size of what? Of the increase that we are talking about here. So the other interpretation, unfortunately, you don't have this in your formula book. Okay, you should have this at the back of your mind or on your fingertips. Okay, so this is what you have. So if you do your calculation and you realize that, okay, your R value is between 0.0 and 0.2, okay, then your interpretation would be that there exists a very weak. So if it is negative, okay, 0.2, or let's say -0.1, which is within this interval, once it's negative, we'll say that, okay, the relationship is very weak anyway, but there exists a very, okay, weak negative relation. So you have to, if it's negative, attach the relation. I mean, the positive in terms of your interpretation, the negative, forgive me, in terms of your interpretation. If your results, when you calculate and you get positive, you equally say so. So all that, as for you adding positive, negative, okay, that one, it shouldn't be a problem. The problem is how to determine whether it is weak, it is very weak, it is what, moderately what, strong, okay, it is strong, then very strong. So we are saying that if your value is between 0.2, okay, and 0.4, then you say that your, okay, there exists a weak, okay, relationship or correlation between your two, okay, variables. However, if it's positive, then you say that there exists, okay, a weak positive or a positive weak, but usually we say a weak positive, okay, relation. Okay, then if it's negative, a weak negative relation, okay, or correlation between the two. And when it is between 0.4 and 0.7, it is moderately or strong, positively or negatively. Okay, then you come to 0.7 to 0.9, that is strong. Okay, then 0.9, okay, to 1.0, very strong. Okay, but if it is exactly 1.0, we deem that as, okay, a perfect relation. Okay, and if it is -1.0, it is also, like I said, a perfect, okay, relation, positive relation or negative relation. It's my point well made. So you should know, okay, the gap here, okay, you can see there is 0.2. Okay, the gap here is also 0.2. Okay, the gap here is 0.3. The gap here is 0.2. Okay, and the last one is 1. Okay, so you are always looking at, okay, from between, so I'm looking at this result, my scale. okay, from 0, okay, to 1. That is the positive side. And the same interpretation is what you have from 0 to -1. It's reflection. So from 0, okay, to 0.2, we said, okay, 0.2, we said we are going to have a very weak. Okay, so you have all the interpretation there. So when we get the values, you come in, okay, look at your scale and use your scale to get the right interpretation. Because usually when you are asked to find, okay, the correlation coefficient, we don't end there. We will ask you to interpret what your result based on what we have here. Okay, so quickly, let's go and look at, okay, our first, okay, question. Okay, any question before we look at our first example? Any questions? All right, okay, so we thank God. Okay, you are fine. Let me see the latecomers. Okay, they are in. All right. Okay, so now let's see. Here, this is all that you are going to do. So we are asked to calculate the Spearman's. Okay, and usually it's supposed to be a capital letter. It's the name of a person. Okay, rank correlation coefficient for the data below. Okay, you calculate and you'll be asked to interpret your result. So let me add, hence, okay, interpret your result. Okay, so take note of that. Okay, so that's what we have. Okay, so all that we are going to do, just like the normal statistics. Okay, if a data is given, okay, in terms of a table, usually we have to extract the data. So I am equally going to have the solution, okay, and extract the data. Then if you add on to your columns, but I will extract the data in the column, okay, form. It came in the row form though. So what do? I'm going to insert a table, okay, and the table that I'm going to insert, you also draw your table. Okay, my number of columns, for now, I'm going to get 2. But usually, if your data is not already ranked, okay, you are supposed to have the rank of X, the rank of Y. Okay, so you introduce 2 more, okay, so making it 4. Then after that, you introduce your D, which will be the difference between the rank of X and the rank of Y. Okay, and after that, you go and find the D squared. So indirectly, you are going to have, okay, 6 columns. Okay, now the number of rows, okay, we know how do we determine our number of rows. So we are going to get what? How many rows do you think this table will give us? Oops. How many rows? How many? Number of columns, 1, 2, but I've added. So the number of rows, okay, we are going to get what? So you know this time around, this will be your rows. So are we going to get 1, 2, 3, 4, 5, 6, 7, 8? Okay, so let's work with the 8 and see what will happen. Okay, then per experience, you know exactly what to do. So this is what I am going to generate. So quickly, you should also, okay, try and draw your, okay, table because you will need it. Okay, so this is what I have. Okay, unfortunately, it's eating into, but I will make it perfect, don't worry. Okay, so let's go and put in all that we have to, okay, deal with. So now, okay, the first one, what do we have? We have our first category to be French X. So I have my first column, which will be headed, okay, French. Okay, and oops, it's in capital letters. So let me make sure okay, everything is in terms of, oops. Okay, you let me write my French. Okay, so French. Okay, so that will give me French. Okay, that is X as provided in the question. So let me move to make everything times new. So that's okay. So let me see. So you construct your table as such. Okay, so now the next column, okay, will be headed, okay, we said German. Okay, so, okay, we write our German. Okay, oops, it's supposed to be capital G. Okay, so German, okay, which is labeled as Y. So, okay, Y. So you take notes. All right, then after that, okay, please, after getting all your values, I'm also going to write the values there. Okay, so let's see what we are supposed to get. I think it will be better if I use ink, or no problem. So let's go. The first one, let me pause and fill my values, then we'll come and look at it together as you also do yours. Then I'll resume. Okay, so okay, so like I said, okay, this is what we are. You extract your two columns. Then if you quote the formula will guide you as to what to do. And you can see that the formula is telling us that, okay, we will need a D before we can square. And the D we know is rank of X, rank of Y. So before you can find the D, we need to go through rank of X and rank of Y. So we add rank X, rank Y, and that is what we are doing. When you are ranking, you assign one to the highest value. The next highest will be assigned to that order. So we've done that of the X. We are looking at that of the Y. We are almost done. Okay, so 88 is the highest, so 1. 73, the next highest, 2. 72, next highest, 3. So 58. So now the next one will be 47. So we assign 5 to 47. Okay, the next one will be what? 44. We assign what? Okay, 6 to 44. And the least, okay, is what? 32. So we assign 7 to that. So now we are going to find our D, the deviation, okay, the deviations of the rounds. Okay, the D that we have there is representing the deviation of the round. So now what do? We just have to come and find the difference. This minus that, this minus that. Okay, so let's go. 0, am I right?
Yes, please.
0, 0, let me calm down. 0, okay. 0. This will give us 1. Okay, 1.
Minus 1.
Minus 1. Okay, then
0.
0. I just want you to see something. Okay, so I made this statement. Okay, but remember, I told you, okay, that anytime you find the deviations, okay, most likely your deviations, if you sum them directly, you get 0. Remember I said that when we were doing the statistics. That's the more reason why anytime you find the deviations, okay, we don't work with the deviations straight away. It's either we find the absolute value of the deviations or we square the deviations and work with it. Okay, when you find the absolute value, okay, then it becomes, okay, the mean deviation. But we are talking about the mean deviation from, the actual mean. Okay, and we have another way of squaring. If you, dealing with the negative, you square, then that will give us the variance, but that's not what we are doing. And the formula, because we know if you work with the D directly, you will get what? Likely get whatever. So it means all that you have here will always be 1. Okay, you always say that there is a perfect positive relation, which might not be the case. So we are going to square. So 0 squared will give us what? Okay, 0. Okay, so then 0. Okay, all of them will be 0 up to, okay, the last part 3. Okay, so 0, which will give us 1. Squared is 1. I hope you are following. Negative 1 squared will also give us 1. And this will also give us 0. Is that clear?
Yes, please.
Okay, so at this point, we are supposed to find, okay, our sigma, okay, D squared. So let me come and write that one here. Okay, sigma D squared. Remember, you left a line, so there is always a rule. Okay, the sigma D squared, and that would be equal to 2. Am I right? Is my point well made? My presentation is not very organized. Remember, I told you ordinarily this table should come here, followed by you quoting the formula, then you move on. But because this room is not sufficient, okay, or enough for the table, that's the reason. Okay. So what I have here, I will need, I know all that I'm supposed to know. So I can say that my R sub x, okay, this implies that my R sub x will be equal to, we said it will be 1 minus 6 times sigma d squared, and sigma d squared is 2, all over n, the number of paired observation. What is n? Who can tell me n, the value of n, the number of paired observations? Okay, so the number of observations will be 7, as mentioned, 1, 2, 3, 4, 5, 6, 7. Right, so it means I'm going to get 7, okay, into, remember we said n squared, so 7 squared, and minus what? Minus 1. Okay, so in effect, we are going, the rest is going to be either a calculator work or, okay, mental. So we are going to get, okay, 12, okay, over 7 into 49, okay, minus 1. Okay, which if you, let me duplicate this, okay, and go and continue there. Okay, so on that note, I can clear this. Okay, clear whatever I have here, especially. Okay, so I'm going to continue, okay, from where we left off. So the whole of this can go now. I'm continuing from where we have that. So that space will be okay for me. So now what do I do? Okay, we are going to have that to be equal to your R sub x to be equal to, okay, 1 minus 12 all over what, 7 into, okay, 48. Okay, so simplify this for me. 1 minus, okay, 12. Okay, you can reduce, so you will do that. You always reduce before you multiply. So give me the fraction of this. Okay, feed it with your calculator and give me the result. I'm waiting. Hello, don't let us waste time. Yes, please. Have I done something wrong?
Yes, it's 48.
48, and I wrote 88. I remember I said 48. Oh. But I wrote 40. I wrote 88. Okay, so 48. So let's do that and see. This gives you. Oh, I'm waiting. Okay, so I'm waiting for the value. Is it 1 on 28?
Yes, please.
Okay, so now you deal with it. And when you are doing this, please leave your answer in decimal, because you can see that the scale for the interpretation is in decimals. Okay, so with this one, you cannot avoid the decimal. Okay, so what will that give you? 0.96. 43.
964. Okay, 40.
43. Okay, and that will be 4 dp. Don't forget you approximated, so 4 dp. Okay, so now we are going to use this, okay, to carry out our interpretation. So in this case, you draw your conclusion. I can draw my conclusion with it. This is universally accepted. So not that because you introduce, you cannot. This one is universally known as the Spearman's rank correlation. So I can conclude with this R sub x. Okay, so going forward, I will even not write the Spearman's, I will just write R sub x. Okay, so now, if you look at this, let's go to the scale. 0.9, okay, 6. Let's see where it lies within our scale. Where does it lie? It lies, okay, here, is that not it? Okay, please, do you agree that it lies here? Okay, so
Yes.
that is between. So once that is the case, then it means we know we are looking at a very strong. Okay, so now let's go and have our interpretation done. So I'll write therefore, okay, or we say with the question use hence. Let me see. If the question use hence, then we have to use hence. Okay, hence. So we are going to use hence. So hence, okay, there exists okay, let me say, what was, okay, so strong or very strong, forgive me, very strong, okay, positive, okay, relationship, okay, between, in this case, you know your variables, so X and Y. Is my point well made? Hello, is my point well made?
If I can't see the right thing.
You can't see, but you could hear, right? So anything that's our, okay, so let me, okay, right. So it's hence there exists a positive, sorry, a very strong positive. So let me clear that if that is what you want me to do. Okay, anything that I write, remember I say it. So you should be able to connect. Okay, so a very strong, okay, positive relationship between the, maybe going forward, I'll take my time. So strong, positive relationship between X and Y. Okay, apart from the handwriting, you are fine. You understand, right? Okay, so
Yes.
let's go and look at the second example. Maybe for maximum 4 will do. Okay, so with this one, basically it's going to be the same thing. Okay, only that. So let me go and copy the table and come in. I think initially before I inputted the table values, I should have copied, but no issues. Okay, so I can copy and do the needful. So, okay, so let me copy the table and come and paste here. So we are looking at what the solution. Okay. So with this one, I think there is no space here. So the solution, we'll write, okay, on top, the solution will be here. Okay, and the question is numbered, so maybe question 2. The other one, I didn't number it. Please go and do the needful. So let's look at this one too. It is X and Y, but we don't have any name associated with the X. We only know that it is X. So we are going to clear that. Okay, so X, not X in brackets, so it will just be X. Okay, then this will also be Y. So take note. Then we'll go and oops. So, okay, then we have rank of X, rank of Y. So let's go and look at our values. 77. Okay, again, let me, okay, pause, but please remind me to resume recording when I'm dealing with the ranks. Okay, so having stated, okay, your first 2 columns, which will be exactly what we have here. Now, what do we do? Okay, we come and rank. The X values, if you rank, the highest is 99. Okay, and okay, it means here 99 will be, so we'll assign 1 to, okay, so this will give us 1. Okay, 99. Hello, are you with me?
It's what's 9 instead of 99? The last.
Okay, this one, right?
Yes, please.
Okay, all right. Thanks for drawing my attention to that. Okay, so then the next one, what do we have? The next one will be 94. Or 94 is the last one. Okay, so let me maybe delete this. It will go up a little on. Okay, to have access to that. Okay, so the last one, 94, will assign to it. Let me do the normal, okay, rather than the equation. Okay, the next one, what do we have? 90, the next one will be 90. Oh, 99, we have 96. So it's 96 rather than should take 2. This will take 3. Is that clear? Okay, then what do we have after that? Okay, no longer 90s. We have a move into the 80s. So 81, okay, will be 3. Sorry, 4. Then what else? After 81, the next one is what? Is it 77? Okay, so 77 will be 5. Okay, then the next one, after 77, we have what? 72. Okay, so that will give us what? 6. 72 will be 6. Okay, then 71 will be 7. Okay, then we are left with 2 more. Okay, 67 will be 8. Okay, then 54 will be 9. So 9 pairs of the observation. So now let's go to that of the y. Okay, we have 99 here, and that will assign 1 to it. So this becomes 1. Oops. Okay, then we have 98. Okay, so that becomes, we assign 2 to that. Okay, then what else? We are out of the 90s. Okay, we come into the 80s. 80s, the highest is 88. So we assign 3 here. Okay, then after 88, any other 80 years, we have 82. So that will be 4. Okay, we've moved out of the 80 column too. So we come to 70. 70, we have 78. So that would be 5. Okay, it's already there. Then after 78, the next one will be, so we move into the 60 column. So the 60, we have 68. So this will be 6. Okay, then, okay, what again? What will be 8? Have we done? We've done 6. We've not done 7. Okay, what will be 7? Which one will take the 7?
66.
Okay, so 66 takes what's the 7? Okay, so this will be 7. Okay, and which one takes what? 8?
47.
47. So this will take the 8. Okay, oops, 8. Okay, then 9 will be what? 43. So 9, this becomes. Okay, so now we are going to rank, find the deviations. Okay, so in this case, sorry, the first one will give us 1. This minus that. Sorry. Okay, so the next one gives us what? 9 minus 7, and that will be 2. Okay, the next one, okay, minus 2. Okay, the next one, what do we have? Okay, minus 3. The next one, what do we have? Okay, minus 4. The next one, what do we have? Okay, 1, positive 1. Okay, the next one, negative 1. I hope you are following. Just the difference. The next one will give us positive 2. Okay, then we'll get 0. Okay, for what we have there. So now we are going to square. So the squares, this will give us 1. This gives us what? 4. Okay, this gives us what? Again, 4. Okay, this gives us, okay, 9. Okay, this gives us 16. Oops. Okay, 16. This gives us what? 1. Okay, this will also give us 1. Okay, this will give us 4. Okay, and that gives us what? 0. Okay, so we are coming to the sum. Okay, so now let's go and sum. But you know, before you even do all that, you would have stated, okay, that your rank sum. So I write, but, okay, my R sub S is equal to 1 minus what? 6 summation of what? D squared, because I've told you, put the formula and let the formula guide you. So I'm assuming it's quoted. Okay, so now what do? We will need a summation of D squared. Okay, so I'm waiting. Give me the total. Yes, Bene.
40.
It's 40.
Mr. Akman, please.
Yes, Bene.
The D column, why is it 2 negative 2?
Why is it 2 negative 2? Where is it? Oh, okay. This one is supposed to be positive 2. Okay, all right. Thank you. Okay, is it this one that you are referring to? Okay, thank you. All right. But you can see that invariably, that's not to say that you shouldn't be careful. It wouldn't affect what you use. You get it? So maybe you get minus half for this error. Usually when you have table, write minus half for each error. Error means wrong value or included value not needed. So now you said it will give us 40. Okay, so it means I'm going to get this to be equal to 1 minus 6 into 40, okay, all over n, which is in this case is 9, into 9 squared minus 1. So for every formula, your first direct substitution, make sure, okay, you do it. So this usually will attract some marks. Okay, and I think you will continue. So let's see how best we can continue. So I will duplicate it and go and do a needful. So on that note, this goes. Okay, I'm going to continue here. So I'm going to have, assuming my continuation is here, so I'm going to have equal to, okay, so this I'm moving up, so you should know. Okay, so that will give us 1 minus, okay, 40 over 9 into what? Okay, 81 minus what? 1. So you get 1 minus 40, okay, into 9, okay, times 80. So you know this will give us 1 over 2. So you are going to get 1 minus what? 1 on what? 80. Am I right?
Sir,
Yes, please. Have I left something out?
Wait.
Come again.
So 6 times.
Oh,
So it's supposed to be 6 times.
I left the 6. Okay, forgive me. Okay, this one wasn't intentional. I don't know why. Okay, so it's supposed to be 6 times 40. So let's write the value there. That will give us what?
240.
Okay, so 24, so 240. So in this case, you get 240 over that. So when you reduce that, what do you get?
1 on 3.
1 on 3. Okay, so let me do the needful and clear that. So 1 on 3. I hope you are following. Oops, I'm breaking the eraser. Okay, so 1 on 3. So now what do we have? 1 on 3 here. Then straight away you move to your decimal. And what will the decimal give you? It will give you
0.
2. So you are going to get 0.666. 0.6 recurring.
Yes, 7.
Okay, so 0.6 recurring. I can deal with the exact value here instead of the 4dp because you were taught how to deal with the recurrent. Okay, so recurring number. So now this is what we have. Okay, so in this case, you know how to do your interpretation. Okay, but usually in your interpretation, just as you saw in the scale, okay, it's usually in 1dp. Usually it's in 1dp. So if you can take it to 1dp, take it to 1dp, or if you want to work with a 4dp, is allowed, or any other dp above 1 is allowed. Okay, so in this case, if I want to take this one to 1dp, then this one will give me 0.7. Okay, that is to 1dp. So approximately 0.7. Let me do this so that I don't indicate the approximation. So now we go to the scale and let's see what is going to happen here. Okay, intentionally did this. So let's go to the scale again. Okay, you can see 0.7. Okay, 0.7 here, 0.7 here as well. So where do you give it to? Hello, I hope I'm recording. Did you prompt me? Okay, yes, I'm recording. So where do you give it to? Any suggestions? Should we say that, okay, it lies within the scale, this interval, or it lies within this interval? I am waiting. Oh, as for this one, there shouldn't be a problem. I'm waiting. I was supposed to finish everything within an hour. Okay, all right. So this is it. Okay, let's look at the original value that you approximated. Okay, so maybe it will give you an idea as to what to do. Okay, the original value in actual fact, what you have here is what 0.6, okay, 6, okay, 6, then 7. Okay, so if you look at the original value without approximating, okay, what do you think? Where would this lie? Will it lie in this one? Okay, it will lie here. Oh, it will lie in this one, is that not it?
Yes, please.
Okay, so usually when you get the extreme values, okay, result, check, use your original instead, because the original is more or less the right approximation, okay, to do your, okay, interpretation. So in this case, okay, we are going to use this interpretation because of the scale. Okay, so what will be our conclusion here? So we are going to conclude that therefore, or let me see whether they use hence. Usually you have to be very particular. Okay, calculate and interpret. So you can also use therefore, but usually when you use therefore for the first one, okay, you can use hence, or in your second conclusion too, you can use therefore. So let me go back. It means now this one rather I haven't drawn my conclusions. So I'll write therefore my R sub S is equal to 0. What? Okay, 7. Okay, I know my original. So I'm using my original, and I would say that this implies that there is moderate, moderately, okay, strong, okay, positive, because it gave you a positive result, okay, correlation or relationship. Is that clear? Okay, all right, so if that's okay, then let's go and look at the next one. I want you to do this one for me and send it right away. Okay, give me how you get your table. I need only the table. Okay, and from the table, I will advise you. So read the question carefully before you start writing, or you start getting, okay, the table down. So I'm going to pause at this point, and I will expect all of you to send your table to me. Okay, so look at what she said, and carefully. So sometimes, okay, when you read question, that's why I said anytime you read question, you have to pay attention to detail. Other than that, don't think it's the usual one that you see, that you are seeing, please. So probe further. Okay, usually, you've been given values. So you get your values, okay, in the table, then later you run. But if you look at the question carefully, look at it. In an examination, candidates were ranked. So what you have here are already ranked values. Immediately you go and re-rank 0. You get a point.
Yes, please.
So you have to be very, very careful. So usually questions will come in 2 ways. Okay, the first way, check whether they are already ranked. If they are not ranked, then you rank. But immediately you see that they are ranked. If you go and rank, it's an insult to the person who ranked. You are trying to tell the person that the person didn't do a good job. So you are rather going to rank, which shouldn't be. So immediately you rank. So it means here, your first column will be rank of what? So you call this maybe mathematics, but you put in brackets rank of X. You get it? And this will be rank of what? Y. Then now you can go and get what? Your difference. So with this one, okay, you don't have to run. So 2 columns catered for. Okay, you only need what? To find directly the deviations of the ranks. Then you move on. Is that clear, my professors? So the key word here is rank. So all of you, okay, you were caught in the web. So I think from here, you should be able to continue. It shouldn't be a problem. How to, it's already ranked, so it's a difference and put the formula substitute. Okay, so let's move on to the next one and see what will happen. Okay, so the next one, this is the situation. So 5 finalists in the beauty pageant were, okay, so Professor Benedicta.
Mr. Hartman, let's go back to that question. I'm confused.
Okay, don't be.
So if you don't bring the RS and RY, how would the table look like? Can you give us a sample?
No, I said, you see, when you get your column, this is how your table is going to be. Okay, your first 2 columns, what you have here, the mathematics, okay, that you write there, is rather rank of X. You get it?
Yes, please.
Okay, and your English will take the rank of Y. So English in brackets, rank of Y on top, wherever, you just have to know because you are going to subtract. So let us know which one is rank of X, rank of Y. So your D will now come and that will be your rank of X minus rank of Y. Okay, so this one, the ranks are already given, not the X. What you have here, they were ranked. So these are ranked values. You get it now?
Yes, please.
Okay, so take note. These are the tricks that you have to be mindful. Other than that, you okay, come out of the exams room with a false hope. All right, okay, so if that's the case, then I'm moving on to the next one. So 5 finalists in the beauty pageant were ranked. So you underline this, already ranked. So it means these are already ranked value. So what you have here, the X here, okay, will be your rank X, or you can choose not to call it rank S and still call it X and Y. But your D here would be equal to X minus Y instead of rank of X, rank of Y, because this is representing rank of X, this is representing rank of Y. Is my point well made? The names that we have here basically to confuse you. Okay, it doesn't have any, so you are interested in these values. Is my point well made?
Yes, please.
Okay, very good. So take notes. Okay, so with this one, you were even asked to, okay, calculate the Spearman's rank correlation coefficient. So don't go beyond. When you get it, conclude. Don't interpret it if you are not asked to interpret it. Don't go and flex your muscles. Okay, so now, okay, let's look at, okay, this question. Okay, so carefully. Okay, all right. So this is what I'm going to do. This time around, I think I'm going to use my tool. So let's see what we have here. The information that we have there. Okay, X and Y, are they already ranked? Are they already ranked? They are not ranked, so we are going to rank. Okay, however, this question is a little different from what we have done, okay, where we needed to rank. Okay, so this is my point. Okay, so in this case, I'm going to be very brief. It's just an information that I would need to throw to you, and that's it. So I'm going to have my first, okay, which will be mock exams, then final exams. So mock exams, okay, final exams. Okay, I will go and rank. So my rank X, which is the mock exams. Okay, rank Y, which is what I'm interested in the ranks. Once you get your ranks, as for the difference, you should know. So in this case, this is going to give us, okay, mock exam, so that is X. Okay, then what's Y? That's what you have there. So mock exams, final exams, Y. Okay, so we know we are going to rank. Okay, so I won't write the values there. They will, you can easily get it. So rank of X, let's see what is going to happen. Okay, so we are going to rank X. So when it comes to the x, what is the biggest value? What is the biggest
93.
value? 93. For the purpose of what I think I have to write it. So let me write 32, okay, 45, okay, 52. Because I'm not typing, I will, okay, finish very soon. So 64, okay, then 71, okay, so 86, okay, 92, 93. Okay, so the highest value would be what? 93, which is 1. Am I right? The next one would, yes, please. Have I left any value out?
If you are 352.
Relax, we are ranking, okay, don't worry. There are 3, so I wrote 2. Okay, so I left 1. I get you now, so no issues. I will remedy that situation, I thought. Okay, so no issues at all. So 52, let me do this. Okay, instead of clearing the whole of that. And let me move it down and create the space for it. Okay, all right. So now this is what we have. Let me go and clear this. Okay, and write the value there. I hope I'm recording, am I? Yes, I am. Okay, so now 52. Okay, they appear in sachet. Okay, so 52, 52, 52. So, okay, I think we are on track now. Okay, only that this must be cleared. Okay, because this will not be the one where the one is supposed to be. So they should go. Oh, where is the eraser? Okay. Okay, so now, okay, let's go. So this will be 1, am I right? So let's move on to the next one, 92. That will give us 2. I hope you are following. The next one will be 86. That will give us 3. Okay, the next one will be 71. That will give us 4. The next one will be what? 64. That will give us what? 5. Am I right? The next one is supposed to give us what? 52. Is that not it? How many 52s do we have?
3.
Right, so you can see that in this data, you have tied what? Observation, meaning observation with the same values. What we usually say, brackets. Okay, I'm about brackets. Okay, so once you have tied observation, you need to do this to assign, okay, the rank value. So the rank value that you assign, this will be how you get it. Okay, look at the position. So, okay, that's normally will be occupied by these what values. So you can see that we are going to look at the 5th, the 6th position, the 7th position, and the 8th position. Do you agree? That will be shared by these 3, okay, observations. Please, should I come again, or my point is well made?
Please come again.
Okay, like I said, unlike what we've done so far, you saw that all the values here were distinct. You didn't get any value repeated. Okay, so meaning you didn't have any tied observation. With this situation, we have a tied observation, and we have what? 52, 52, 52. Okay, and we are saying that, okay, we've ranked, okay, from 1 up to what? 5. Okay, so now we were looking for the 6th position, then that gave us this. And you can see that we have 3 observations. Okay, and the 3 observations, each one is supposed to be assigned a position. Okay, so ordinarily, if I was supposed to rank this, I'm supposed to get the 6th position, the 7th position, and the 8th position will be occupied by this 3. Is that clear?
Yes, please.
Okay, however, you don't know which one do you give the 6th, the 7th, and what, and the 8th. Obviously, you know, if you give it to the first 52, the second or even the 3rd, you are not fair. So what we usually do is we find the average of the positions, not the average of the numbers, the average of the positions that they are supposed to fill. And we said the positions would be what? 6th, 7th, and 8th. Is that clear? So we are going to find the average of 6, okay, 7, and 8. And you know how many observations? 3. So it will be over 3. Do this, then give me your results. 7. What is that giving us? 6 plus 7 plus 8, all over 3.
7.
7. So it means you assign 7 to all of them. So to be fair, so 7, 7, 7. But however, you should know that just as you can see, the 6th position, the 7th position, and the 8th position taken. So the next observation should take what? The 9th position. Is that clear? Don't go and assign the next position 8 because you see 7, 7 here. Because this 7 is going for 6, 7, 8. So the next one should rather take 9. Should I come again, or my point is well made?
Please, is well made.
Okay, so the next observation, which is 45, becomes 9. And this one becomes what? 10. Okay, then you come to, let's see, okay, 41. Okay, do you have any tied observations here? Can you see any tied observation? Okay, because I wanted to explain the tie. So if there is no tied observation, then it's well within your range how to rank them. Is that clear? So once you rank that, you go and find the difference, and okay, obviously you know what you are supposed to do. Is my point well made? Hello, my professors, is my point well made? Okay, all right. Okay, so now let's go. I guess I'll take your silence to mean yes. Okay, so the next one. These questions are carefully selected. And again, okay, let me do the needful. Okay, the Spearman is supposed to be capital S. Okay, all right. So this is what we have. Okay, the deviations between two ranks are what we have here. So I want to ask you, how would you deal with this? Any ideas? What have you been given per the information here?
You've been given D.
You've been given D. So when you build your table, okay, the first thing that you write will be D. Okay, after that, then you come and find D squared. Then you put your formula and you do the needful. All correct?
Yes, please.
Okay, so take notes. Make sure you read the question. So I've given you, okay, indirectly 3 different situations. The first one is the normal one where the observations are not ranked. So you rank them. Okay, then 2, where the observations are already ranked. So it means from the data, your first category will be your rank S. Your second will be rank Y before you go and find what's the difference. Okay, which will be the deviations. Okay, then now, okay, we have a question which is giving us the deviations between the 2 ranks. And remember, the deviations between the 2 ranks is what we represented by D. So it means you've been given D. So all that you need to do is create a column for the D squared. Then, okay, you know what to do. Go and substitute that into your formula. So here the observations will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means your N will be what? 10, because you have 10 head observation okay, deviations gave you this. Okay, so at this point, okay, let me see how you can find your way around this question. Okay, so this becomes your assignment. Okay, so let me see how you can find your way around this. Okay, it looks a little confusing, but it shouldn't be. So your result that you have there, are they already ranked? Okay, so you let me leave it to you do it the way you understand. Okay, then you send it to me. Indirectly, I want it to be a classwork. Okay, so by 7 o'clock, okay, please make sure this is well submitted. Okay, so if that's the case, if I realize that you did what was expected of you, then I know that the topic correlation and regression indirectly, okay, done. Okay, as for the graph, okay, basically, it's a long time the graph came. Okay, but okay, when you read the questions, you can really, okay, relate. Not too technical like this one. With this one like this, if I didn't give you the information that sometimes the question could come in its ranked form, you know that definitely you go and rerun. Okay, as you said, so you have to be very careful. Okay, so thank you very much. Okay, we have to end the class here. Okay, and you will meet this afternoon at 4. Okay, for core maths. Okay, I'm thinking of maybe doing bearing. We are done with what do you call it? Logical reasoning. Okay, and the logical reasoning related maths, we'll do it in due course. That one is just basic information that I need to give you to have your table. Okay, so on this note, thank you very much. I'm waiting for the solution to the assignment. Okay, the class assignment here, I'll put it on the platform anyway. Okay, maybe I'll capture the actual question. Okay, and it will come in a better form rather than this, which is handwritten. Okay, so thank you very much. God bless us all. Have a lovely day. Make sure you practice. You have A+, you have whatever. Check. Okay, try some of your hands on some of the questions. In fact, all the questions if possible. Okay, and if you have any challenges, you can get back to me and I'll address that. Okay, so bye-bye.